This video is part 2 of hypothesis testing. So this video is going to demonstrate tests of mean differences, but if you have not watched part 1, which is a one sample t-test, then you may want to start there so you can see how to do a one sample t-test. Okay, so if we want to do a 2 sample t-test procedure, we can find this under the Analyze menu. Analyze. And we're going to go to Compare Means. And we're going to go to Independent Samples t-test. Okay, when you click on that, you'll see a dialog box will open up, and you need to specify your various test variables, or the dependent variable first, and then you'll need to specify an independent or grouping variable. Let's test the null hypothesis that white people and black people work the same number of hours each week by using the variable hours1. That's the same variable I used in the previous video. This is considered a null hypothesis because we are testing whether or not whites and blacks are equal to one another. The fact that we're testing whether or not they're equal to one another makes it a null hypothesis. So we're going to look for the variables hours1, all right, and that's going to be our test variable. And we're going to look for the variable racen1. So there's a couple different race variables. Choose this one, racen1, and you're going to put that for a grouping variable. Now, you're going to see that question marks appear next to this variable, this grouping variable, and this is considered your independent variable in this model. And you need to indicate 2 values to define the 2 groups or independent samples. So click on the blue box that says Define Groups underneath the variable, and then put 1 for group 1 in your first box and 2 for group 2 in your second box. And this allows us to compare white individuals and black individuals. Anytime you do this though, make sure you look at your variables to know which group is which when you are assigning values to groups. Otherwise you could have a mistake. Go ahead and click Continue, and then click Paste to run your syntax. Click Paste. Okay, so you can see here we're doing a t-test and it has groups. This is our variable with groups, and our dependent variable is hours1. Go ahead and highlight the syntax and click Run. The output from the independent samples t-test is a little bit more detailed than the one sample t-test output, and it contains more information than we have discussed in this particular chapter. The first part of the output displays the mean number of hours worked for whites and for blacks. So if you go to this first box where it says Group Statistics, you can see the mean for white people is 42.43 and the mean for black people is 41.46. You can see that our ends are very different. We have 1,940 white people in our sample, and we have 368 black people in our sample. It also gives us the standard deviation for both groups and the standard error of the mean. So you can tell right off the bat that there is a difference in the number of hours worked between whites and blacks, and you can take 42.43 and subtract 41.46, and you can see that there's an actual difference in the sample of 0.97. And we want to know if this difference is statistically significant. And so that we can do by hand, but that number, that difference, is also down here under mean difference. So one of the important things about calculating the t-statistic is whether the variances of the 2 groups are equal. If the variances are assumed to be equal, then you can use a simple formula to calculate the number of degrees of freedom. However, SPSS can take account of those times when the variances are unequal and still calculate the appropriate t-statistic and degrees of freedom. To do this, SPSS does a direct test of whether or not the variances for hours worked are identical for Black and white individuals. We didn't really discuss this test when we did our by hand calculations. This is called the Levine test, and it's in the second part of the output under the independent samples test box. The test has a null hypothesis that the variances are equal. SPSS reports a probability of 0.001 for this test. So if you look here, that's 0.001. And this is what SPSS is reporting as a probability for the Levine test. So what do we do with that number? This is statistically significant because it's less than 0.05. So therefore, we can reject the null hypothesis that the variances are equal, and we would conclude that the variances are not equal. So if this number here is less than 0.05, then we need to make sure we use the second row of output, this row right here, okay? So we're going to say that equal variances are not assumed because this is statistically significant, and so we're going to use the second row of data. And you'll see that these numbers are very, very similar, but the second row adjusts for the fact that the variances are not equal. So based on that decision, we know which t-test to use. And so we're looking at that second line. SPSS calculates the exact significance for us, so there's no need for us to look in Appendix C. When you do this kind of calculation by hand, you have to use Appendix C and look up the p-value. But when you do the calculation with SPSS, we can see the statistical significance is right here in this column, and this is our p-value, and it's running a two-tailed test. And you can see our p-value is 0.211. This is much larger than any alpha that we would set. It's larger than 0.05, 0.01, 0.001. So we can conclude that we cannot reject the null hypothesis. And remember, the null hypothesis would be that blacks and whites work an equal number of hours per week. So the difference between 42.43 and 41.46 in this particular sample is not big enough that we can conclude black and white individuals work a different number of hours per week on average. If we want to do a one-tailed test, which SPSS does not directly list, then we could easily calculate this number. We would specify a directional hypothesis, and then we may want to calculate this number. Simply take the probability reported by SPSS and divide it in half for a one-tailed test. So you would take your number here, your p-value, and divide that in half. You can try this procedure with different variables like sex, and you can group people by sex, by race, by other demographic characteristics. And you can do mean difference tests.